Well, hello, welcome to another math lesson. We are starting a new unit, and hopefully you have already taken the survey, so I have some idea of what you're ready to do. We're going to start, before we start getting into volume, I've decided to do a little review on area and perimeter, just to make sure everybody understands that. So, we're going to apply the area and perimeter formulas for rectangles in real world and mathematical problems. Before we get there, let's just take a look at what perimeter is. Watch this little animation here, and it's already in progress, so we'll look at it again in a minute. But if you notice perimeter, we're counting the lengths of the outside. We're going around the edge, the perimeter. Watch this one now. And we're adding those amounts together. And what's interesting about this particular animation is that even though they look very different, they have the same perimeter. Okay. One more time, and then I want to show you an animation on area. Notice how you add each of the sides together. Okay, now let's take a look at an area. It's probably already in progress also. Yep, we're going to have to wait for it to go back to the beginning. Area now, as you can see by the color, it's the space on the inside of an object. That fills up. And we're talking about, in both cases, we're talking about a two-dimensional object. Okay, we're not talking about three-dimensional yet. That's when we get into volume, where it's going up to. But right now, we're just talking about something flat. Okay, so area, as you can see, we start out counting 1, 2, 3, 4, 5, and then adding the 5s. But then it stops and it just multiplies. Remember, multiplication is a shortcut for addition. We could sit here and add up the 5s because each column is 5. 5, 5, 5, 5, 5, 8 times and add them up. Or we could just multiply by 8 and get 40. Much simpler, and we don't like to work too hard, do we? All right, so here's our two formulas. The perimeter is actually 2 times the length plus 2 times the width. Now people ask me, which one's the length, which one's the width? It really doesn't matter. It's whatever you want it to be, because if we make 6 the length and 4 the width, or 6 the width and 4 the length, we're going to get the same answer. And the same thing with area. We're going to get the same answer. So don't fuss about that. All right, so let me show you how to find the perimeter real quick using the formula. So perimeter equals 2 times the length. I'm just going to call 6 the length, okay? So 2 times 6 plus 2 times 4. So 2 times 6 is 12. That was supposed to be a 2 dot there. And 2 times 4 is 8. So perimeter is 20. Now, the area is even easier. Area is the length times the width. So 6 times, oops, 4, not 2. I was thinking that wasn't right. Yeah, there we go. 6 times 4, which is 24. So the area is 24. Now, notice something else. I want you to start noticing units, and I didn't mention that before. When we're talking about perimeter, since we're only adding them all together, so we're adding 6 twice and 4 twice, we've got centimeters. All right, because it's a single, it's just a one thing, a one-dimensional measurement. Okay, it's like measuring with a ruler or a tape measure. Okay, so it's one dimensional, it's just long. But when we multiply the two sides, we're not only multiplying the 4 and the 6, we're multiplying centimeter times centimeter. So we've got centimeters squared. So don't forget about our units. All right, that's going to become important. And there may even be some trick questions on tests and things that you can eliminate because you're going to see that the units are wrong. Let's say I had a question that said, what's the area of this rectangle? And one of the choices was 24 centimeters, along with 24 centimeters squared. And let's say I said 20 centimeters squared. Right away, you could eliminate the one that was not squared and say, oh, that can't be the area because it's not squared. It's not two-dimensional. See, area is 2 dimensions. It's 2 directions. Okay, where perimeter is just all the way around. You may be changing like direction, but it is just one dimension because you could put a string around it and then make it would still be the same thing as you saw on the different size or different shapes, they can have the same perimeter, even though they're very different shapes. And I would have to say they were different areas too. All right, your turn. Find the perimeter. Okay, now find the area. This is the same rectangle. Now I want to show you something that is even easier, if you want to think about it this way, is the perimeter area of a square. So when you're given a square and you're told one side, you're done because you know all the sides. So it makes sense. Instead of it being 2 times the length plus 2 times the width, well, 2 times the length, let's say, 2 times the length if the side is 5, 2 times the length, okay, plus 2 times the width. We've done the same exact thing twice, right? 2 times 5 is 10, plus 2 times 5 is 10. So the perimeter is 20. Down here, I've done the perimeter with the exact same, with the perimeter, with the square perimeter formula, and I got the same answer. So as you can see, it doesn't matter which way you do it. If you can just remember the rectangle one, then it'll work on the square too. It really will. But if you can remember this, it's a shortcut. So over here, we've got 4 times, where's my pointer? Here we go. 4 times the side is the perimeter, and the side squared is the area. And remember, we learned that in Pythagorean theorem. Remember, a squared plus b squared equals c squared. You thought you were done. No. Yeah, that's what we were doing. Remember, we were getting the area of each of the 3 sides of a right triangle. Well, this is exactly it too. Pretty cool. It all comes together. All right, your turn. What is the perimeter of this crazy square with the side lengths of 12? All right, same square, only I want the area this time. Side lengths of 12. Okay, so Mrs. Paston wants Mr. Paston to build her a fence around her garden. I guess apparently she's having some trouble with somebody. Anyway, her garden is 10 feet long and 8 feet wide. How much fence does Mr. Paston need to buy to build her fence? So, we are talking about perimeter here. Think about what she wants. She wants a fence around her garden. Okay, around it. That means perimeter. So our perimeter formula was 2 times the length plus 2 times the width. And it says here, 10 feet long, 8 feet wide. Ha! Easy stuff, right? So 2 times 10 plus 2 times 8. 2 times 10 is 20. Plus 2 times 8 is 16. So Mr. Paston better buy 36, let's see, it was feet. Go back and look at the original problem. He better buy 36 feet of fencing. Might want to go a little bit more just to be on the safe side, but you never know. Okay, so that is our real life problem from Mrs. Paston's world. Here's mine. And you get to figure it out. Mr. Horn is a crown molding expert, let me tell you. He could do this so fast in his head, it's not even funny. All right, he might want a calculator. You figure it out. Well, that was quick and easy, right? Hopefully that made sense to you. And hopefully now these beginning animations make a little more sense. Isn't that fun? Take a look at the other one for area one more time. If it didn't make sense at the beginning, I'm hoping it did at the end. All right, thanks for watching. I know you're going to knock this one out of the park.